Right. So, hopefully the battery will last this time. We're on question 7. We've just established that. Do you remember where these came from? So it's quite a nice idea, actually, isn't it? If the kiln does 15 dishes, then each dish takes up a 15th of the total. So that's how we get a 15th of X plus a 50th of Y plus a 200th of Z is less than or equal to the total available space in the kiln. Now, it said where A, B and C and D are integers to be determined, so we are going to have to multiply by these values to get rid of these on the bottom. If we multiply by, what can we do? If we multiply by 200, that's the kind of obvious thing to do to start with, then that, what does that give us? 200 over 15 is something nice, isn't it? 40 over 3. Is that 40 over 3?
Yeah.
That would give us 4y, and that would give us z, is actually 200, having multiplied by 200. Now we need to multiply by 3 to get 40x plus 12y plus 3z plus 3 equal to 600. One of the slightly unusual things about this question, we've seen these before, where it's been this style, but it's given us a big hint as to what we're looking for, and we've been able to check the answer, and they didn't really do that with this one.
I don't suppose you've got Mitch Hopper with you.
I haven't got Mitch, no.
Blur that bit out.
I don't know how to edit it.
Why don't you start a hashtag web
Just carry on.
Just carry on.
Just carry on. Nobody heard that.
Hashtag
I'm watching. So.
Nobody's watching, didn't you just say? Okay, right. Other constraints come from the amount of clay required, the potter's time, and the customer demand. The potter wants to maximise the profits P from selling the dishes mugs and pots. This leads to a linear programming problem, which is represented here. After one iteration, so we can't even check that we've done that first bit right, but I guess it was just standalone 3 marks, wasn't it? After one iteration, the table looks like that. Which column was the first pivot chosen from? Well, the first pivot ends up with that column having just 1 and otherwise zeros in it, doesn't it? So it must have been the X column, and I think everybody got the mark for that. It must be X, because that's the column that is a 1 and otherwise zeros at the end of one iteration. Carry out a second iteration. So the question wants us to, can I move that higher up so I can see them both? Just do the next iteration on that tablet. So as we work through that, and I guess a few people didn't kind of give us the working space to do it, did it? It just gave us straight into that, Jacob. So the first thing that we're going to do with this is we are going to decide which is going to be our pivot column. We've no choice here. Did most of you work on the exam paper for this bit? Did you do that? Because you need to do the working values, don't you? And it didn't really give you any room to do that. Is that right? So as you carry out the second iteration, I guess you will have to, you'll have to mark that.
Did
Has
you
it
run
gone?
red again? No, you run red there, like the battery thing.
Oh, that's not good maths, is it? You mark that.
I'll have to do some quick maths then.
Okay, with 1 plus, I don't know. Right, that was good. The only thing that we're going to be able to calculate here is 6 divided by a quarter, which is 24, and 10 divided by a quarter, which is 40. So that's the one that we're going to pivot on. So we're going to pivot on that column. In order to make that into a 1, we need to multiply by 4. So that is row 3. There's not really space to do any of the working out for this, is there? So, so this is going to be, that's rows 1, 2, 3, 4, and 5, so 6, 7. Row 8 is row 3 times 4, and we fill in that row. What's that? Minus 3 and 24. We then need to get the other values to be zeros. Now actually it's a bit messy, isn't it? We could probably have worked better using the original one. So row 6 is row 1. What could we do? It might be better to do plus 3 times that. Would that be a better way of thinking about it? Rather than doing 3/4 of that one, it doesn't really matter. So it's row 1 plus 3 times the old row 3. And that gives us 1, 0, a half plus 3 times a half is 2. That's a 0. Minus 3/4 plus 3 times a quarter is 0. 0 plus 3 times 0, 3. 0. 1.25 plus 3 times 3/4 is minus 2. Did we get minus 2? And 50 plus 3 times 6 is 68. And that gives us the top row. That's a minus 1, isn't it? I added that. Oh, 1. That's wrong. Is it still saying it's going to run out of battery?
It's gone, like the red bit's gone now, so it's just literally a battery sign that's about to go.
It's exciting, isn't it? Just kind of...
When is it going to go?
Where's it going to go?
Have you got a charger to plug in?
No, it doesn't plug in. I need a new camera.
Get like a YouTuber camera.
A what?
Like all the YouTubers have, and they have their little light ring.
You need to get some AAAs.
It uses double A's.
Yeah, but then got an extra one.
What?
Extra A.
An extra A. Good. I like the way you're thinking.
You haven't got long left. Let's go in.
Stop giving a running commentary on the thing going. What are we doing? 7 is row 2 plus a half of row 8. That gives us 0, 0. 1, 0, 1, 2. Have I even done that right? 0. Minus 2.5 plus a half of that is minus 1 again? No. No, it'd be minus, wouldn't it? So it's minus 4. And then 20 plus a half of 24 is 32. And that was what it was supposed to be. And so on. Row 9 is row 4 plus 7 times row 3 gives us 0, 0, minus 8 plus 7 times 2 is 6, minus 7 plus 7 times 1, 0, 0 plus 7 times 4 is 28, that was already a 1, minus 10 plus 7 times minus 3 is minus 31, yes, and this is going to be fun. 200 plus 7 times 24 is 368. And the bottom row, row 10, is going to be the old row 5. That's well, actually just take away row 3. Take away, yeah, row 3. I've used row 8 there, haven't I? Not row 3. So 5 take away row 3 gives us 0, 1, half take away half, quarter take away quarter, 0, minus 1, 0, and a half.
Why are you just taking away
Oh,
row
it's-
3?
Oh, it's not just that. Because it was a quarter, I need to take away the quarter.
Oh, okay.
So I could just, instead of using a quarter of row 8, I can just use the original row and that would work. That gave us a 1, didn't it? And then we've got a 4 there, because that's 10, take away 6, which is 4. Brilliant, so that's that. And you've got 4 marks for doing that. Then the question said, what did the question say? The final tableau is there. Use this tableau to state the number of dishes, mugs, pots that should be made each day and the potter's profit. So the profit is 72. He should make 0x, 0y, and 36 is the value for Z. That's what we get from those. So that is no dishes, no mugs, and 36 pots. Profit of
Perfect.
oh yeah, of £72. That was that bit. Finally, the question said, if the potter makes this number of dishes, mugs and pots, why might the profit be less than the amount given? Well, that's the bit where you just do all of that kind of general interpretation stuff. He may not be able to sell all the ones that he makes. So the demand might not be enough. That's it really. Goods may be cracked in the kiln. They may not all. That's how many he can actually create, but they may not all be good for selling. All of those kind of ideas. That's probably the easiest way. You may not sell all produced. We made it to the end of that expiring, didn't we? So that is maths.
Oh.